That picture you see, I have it right here. It's a little button. I'm gonna let you see them over lunch. It's a little button. You start.
Okay.
We're just gonna interrupt one another. Yeah.
Okay, so to start off here, we have what we've all kind of come together to talk about today. And so there's lots going on here, talking about addressing social societal issues within mathematics classes. The things that we pulled out of this to focus on right now are what we highlighted in red here, and that's positive learning experiences and agency over mathematics, and with an eye towards fostering a sense of belonging and inclusion. So that's kind of what we're excited about.
I might say when I first read this, I thought, oh, I better construct a mathematical model, sort of an evolutionary model that shows why it's profitable, why it's better for us to work together rather than alone, and we track the model, and then I thought, well, who wants to study a model like that? We all know it's fun to work together, so let's just work together. And so that's what this idea is, working together to do something. And so the idea came actually when we were trying to figure out what to do with our summer math camp, our girls' math camp last summer. Tell them about the camp.
So every summer we have at Queens a week-long or just less than a week-long camp for girls to come and meet new people and do some math. And so they stay in residence, and then we spend the days with them doing different activities. So we always kind of come together at the beginning of the spring and summer and have to kind of grapple this question of what we are going to do.
And they're all the way from grade 8 to sort of even some grade 7, certainly grade 8, all the way up to say grade 11. Yeah.
So it's a range of grades, and also we get returning campers, so we're always having to come up with new ideas. So this past summer, Lauren, who's pictured here near the end, she came up with the idea that we should all make buttons, which Peter has some here. So she had to convince Peter, which was a bit of a tough sell, because he was not sure this was the way to go, and it also required investing in a button maker.
I didn't know what a button was, actually.
So she did the tough sell though, and she eventually convinced Peter to buy this button machine off of Amazon, which was very fun.
Which was amazing.
And then he got very into it very quickly.
Now every classroom needs to have this button machine. It came after 2 days. It came $100. That's all it needed.
Yes.
And it's the most amazing thing.
So then we decided we had to talk about how we were going to make buttons and what that meant. So Lauren went away and figured out how to use the machine. And then we started kind of brainstorming how exactly we were going to get the girls to design their own buttons. And then we went to Peter's other favorite thing, which is Desmos. And we used it as an opportunity to be working with functions, and not in necessarily a formal way, but more in a chance to have an experience with them. So we weren't getting too worried about function notation or sitting down and defining them. Some of them, as Peter said, are in grade 7 and 8, so it was new to them. But really just more having an opportunity that they were playing and creating with each other, and getting to spend time with functions, which can be hard to do, to find ways to spend time with functions.
So kids don't really like functions. I don't know if you ever noticed, they like the geometry and they like playing with numbers and even like simple probabilities, and then, oh my God, in grade 11 we come to functions. And so, but how are you going to build this button? And you need lines and areas you can color, and you like beauty, and beauty comes from structure, from complex structures that are somehow simple and somehow reach out to you and say, this is beautiful. And so Desmos is a really good tool for moving curves around and intersecting them and so forth. And of course, to do that, you need to know kind of how to code. and you need to know about functions. Isn't that right? No, that's not right at all. You don't need to know how to code, because Desmos, you just write math equations. And you don't need to know how to do functions, because all you need to know is how to do something. You don't need to know it all, you just need to be able to do something. So tell a story about that.
Oh, yeah, okay. So, we've made this connection to, you don't need to know how everything works in order to do something. Yesterday in the train station, because Peter was trying to make a call, which then required him to.
Trying to make sure the taxi was on time.
Yes, and so he needed to then punch in, he got to a menu, press 0 for this, press 1 for this. But when he looked at his cell phone, the keypad had disappeared, which he was very frustrated about. So
Then you know how to press 0. How the hell do you press 0?
So then in the train station, I said I showed Peter how to do this, but he said that he didn't want to know how this worked or why it worked, he just wanted to know how to do it. So don't explain to me, just show me, which is a connection he made to the same thing with working with functions, which is we didn't spend time kind of digging into how some of these things worked, it was just an opportunity to do things with them.
Okay, give me the definition.
Okay.
So, how do we get, I'm gonna construct this one right here, the one in the top, right-hand side. So, how do you do this? Well, you want, okay, that's good.
It's not sharing. Do we stop?
Why is it not showing? No, do this, this,
No, we're there now.
but just the most one? Yeah.
It's this. Yeah, just try.
I don't know.
Okay. What are you trying?
So okay, so what do you do to build one of these things? Well, you say to the kid, okay, I'm gonna show you a function. It's called cosec, and they may be in grade 10, so they may wonder, well, I know what cos is, it's this triangle thing, and no, it's different, it's a curve. So as a gift, I'll give you, so put in just y equals cosec. I'll give you y equals cosec. It's a nice curve. There it is. And now that's an object you're going to manipulate to make more complicated curves. And so an idea is reflected in the x-axis. Do you know how to do that? So they do know about coordinate grids. So we get them to understand in terms of coordinate grids, we get them to understand reflection in the x-axis so that they get, and so that would be y equals what? And they, in sort of an experiential way, they say, change the sign, plus minus. You see, so they put in y equals minus cos x. And they could put in y equals absolute value cos x, and that would do the same thing. That's interesting. And then you get that. And you, oh, that's nice, they say. Okay. Looking for ideas. Well, how about running the same thing down the y-axis? I think you're gonna get the grid. So how would you do that? Well, they may have no idea, but what actually is this x and y all about anyway? So get them to understand, because they need to do that, that all you have to do is interchange the x and the y. And that's an example, so do that. Then you want the next one would be x equals y cos x, and so forth.
What you want?
X equals cos y. See? And there, oh, see, now I want to reflect that. And so do that with that, yeah. And so you see what we're doing. They're working together in groups, and they're having these, and they'll say, okay, I want to do this. I want to make this, and so forth. Notice that little thing in the middle. That actually looks like a circle, but it isn't. It's just a curve made out of cos curves. So that's pretty neat. And then somebody asked, well, I want some curves that come in and swoop out. And we could use parabolas, but you say to someone, you say to them next, look, I'm going to show you a really cool function. I'm gonna write y equals cos x. So I'll write y equals cos x again. And then I'm gonna change that cos. I'm gonna put an h after that cos. This is really groovy. This is called a hyperbolic cosine. Now, and there it is, look at that. It right touches down on the, that's kind of magic. Okay, there. Now I want to turn that one upside down. I want to do a reflection with that. And then I want to do it going sideways too. So now they have a task. How do I work with those X's and Y's to do that? And well, I think we've probably said enough. You can see how it goes. So go back up to the top. You can see what we're doing here. So turn that on. Then, oh, you'll have to highlight all those things. So. And then,
This one?
Kosh, yeah. And, those, and then, so there's some, yeah, keep going. Oh, yeah, there we are. And then take away the grid and all the stuff they don't need, that's over here. Yeah, and, axis numbers. We don't need all those things, and there's, at the very bottom, there should be a way of.
It's a pretty cool button.
And that's the, there it is right there. And so you put it in the button machine and there it goes. And that's experiential learning. That's working with curves to design something and doing it together and learning things, how to do things that later on you're going to have to learn in our flawed way of instructing. So I guess that's it. So happy to answer questions, ideas.
How did you get the picture into the button machine that you can?
That's technology. Yeah, you cut it out. So you print it, take a pair of scissors and cut out around that circle. And then, so go back to the very beginning, the very first slide. So you can see the button again. Then you just put the circle, the little paper circle, that's just paper. You put the little purple thing in that machine and you take that big handle and go, and out it comes.
Can I keep it?
Whoa. You can switch that one down further. This is quite a table. I thought you were a volleyball player, Kitty. Okay, shoot it down. Yeah, anyway, I couldn't believe it was that good. And now they get to take it home. They get to wear that button. I made this,
Right.
which is kind of neat.
Did you ever see,
I got an idea.
did you ever see Shirley Darwimple? She did a presentation at Fields, I think, of using functions and families of functions to create art. And it's quite similar to what you were doing.
Now, was Desmos around in those days? Because Shirley was doing that a long time ago.
She was doing that a long time ago. It was probably 15 plus years ago.
Yeah,
She might have been doing it in Sketchpad. We did have, like, Sketchpad was alive. I think
yeah.
GeoGebra might have been her.
Only just Sketchpad.
Geometry Sketchpad.
Yeah. Geometry.
I have to check, but I think she was using Desmos as well. I have to check, but it's right in line. And you're quite right. The functions lack a little love, but you can do beautiful things with them.
There's a lot about in the new curriculum about modeling and all that stuff. But because kids are attracted to real world applications, right? But we kind of think kids are attracted to art and beauty even more. Oh, and they're not if either or. You can do them together.
Go ahead, Wes.
So I'm a huge fan of Desmos, of course. And as you know, I let my students use their cell phones on their exams, things like that, their tablets. And so what I want them to be doing on their calculus exam is pulling up Desmos and using it to support their work. But what I'll give them is a graph that has some complicated function, some functional form. I don't know, x over e to the x, something that you're not going to easily guess at. And then I'll just give them the graph that as a question on the final and say, what function is this? The idea is they're going to go into Desmos and they're going to experiment and they're going to move things around. They're going to try sliders and like put variables for coefficients and slide them and see how it changes the shape. And then ultimately arrive at something. I think it's great. I mean, the buttons are wonderful too, but we could be doing this all times, always, throughout the curriculum.
So this calculus book I wrote a long time ago, it had pictures of curves and then construct a function which did this and so forth. And there was certainly no Desmos around in those days. And, it's a very powerful way to play. Play is such a huge word. So.
And I think it also reveals so much of the students' thinking. They're not guessing at stuff.
Yeah.
It's an ansatz, an educated guess. That they're like, oh, well, that should have, I can see from this asymptote, it should involve an exponential function. So I'm going to include that in some way. Oh, but that's not working. Oh, I can see I need a coefficient that's going to expand it. Right? So they, it reveals more than just like graph this function, which is a stupid question.
There's all this stuff in the ministry documents about moving parabolas by adding a and you move it to the side and then you move it up and then you stretch it out this way, and that couldn't be done in such a boring way. But having them be building things and constructing things where they want to actually widen the curve and so forth, well, then you're really understanding what's going on. Makes a huge difference. I think we're done.